the stream. I will start recording though. All right, hello everyone. So we don't have that many topics because, well, a lot of people are going to be giving reviews and other things like that. So I was half planning to cancel, but G asked me to present ScubaDuck. So ScubaDuck is a Scuba re-implementation I did while I was on parental leave. Entirely vibe coded. I only wrote a few commits of code, mostly to set up the original environment. And wait, what's going on? Why am I sharing that screen? Sorry, just a moment. Okay. And I don't know. I thought it was a really enlightening exercise, and I actually did write a blog post about it. So I'll redux some of the blog post, but there aren't that many people here, so I think this would be more interesting as an interactive session. So I do earnestly think that there's a lot of opportunity to do vibe coding for various things while we're working on things in the PyTorch project. And so hopefully this can get some of the creative juices flowing. So I think a good place to start is, what the outcome, what did I make? So here is a live instance of the ScubaDuck interface. And what I've loaded up into it is the New York taxi cab data. So what's the New York taxi cab data? Basically, they collect up data from all the rides of taxis in the city, and it gets published in a public data set that you can just go look at. So it's a Parquet file, loaded it up to DuckDB. It's called ScubaDuck because the backing data store is DuckDB, an in-memory analytics database. And then I built this UI on top of it, which just lets you look at it. So if you ever used Scuba before, many things should look familiar, right? So we're in a time series view. There are a bunch of settings for things you might want to look at. You can select what columns you want to look at. So in this view, what I have right now is I said, okay, tell me what the fare amount was, plot it out over time, and to aggregate sum them all together. And there's some granularity that is whatever. So for the given period of time, we collected $1.6 million of the taxi drivers collected $1.6 million of fare. By the way, why is there this big spike over here? Well, this is January 20th, aka MLK holiday. So I guess people take a lot more taxi rides during the holidays. You can also see the strong periodic effect here because people take more rides during the day and then less at night. I think that's what's going on here. And so like Scuba, you can also ask it to, go ahead and do different sorts of things. So we can go look at the table view. We can say, okay, how many records do I have in the database? I have 3.4 million records. I can say, okay, let's group by something. What if we group by something special like, how many passengers there were? And then what do I want to look at in the table? Oh, let's just look and see, once again, how much people are paying depending on how big, how many passengers there are, right? And so we can see, well, I don't know why there's two entries here. But what we can see is that, one of these is probably null and the other one is a 0. We see that there are 24,000 trips that are coded with 0 passengers riding, which is clearly wrong. It's probably a coding error in the data. And,
Well, if you make a lot of money out of it, that's okay, I guess.
I know, right? And then the majority of rides are with a single passenger, and sometimes people, I don't know how they fit 9 passengers into these cab rides. Who knows? Whatever. You can do all these. Go ahead.
Do pie chart. Can you do pie chart?
No, I can't do a pie chart. So I only implemented three views. That's basically what it is. So if you got a Parquet file, you got a CSV file, you got a database, it's got some data, you want to look at it, you're a scuba maniac like me, just load it up in ScubaDuck and click around and see what you can find out. It's very, very accessible in this way. Any questions about this before we go? Here's the group by in the time series gives you, separate lines for, how many passengers there are, for example.
So the spike is actually only a single passenger.
Yeah, apparently. Isn't that strange? I don't know if that's a coding error or not. Go ahead, Boston.
So you said you did this with vibe coding. I've heard a bunch of different definitions of vibe coding. So what definition
Yes, so
do you use?
I'm using the old Andrej Karpathy definition of vibe coding, which is that once I had set up the initial... So I did code like the initial environment, but then after that, all I did was I kept feeding OpenAI Codex prompts. We'll look at some of these prompts in more details. Like everything I wanted to do. So like, for example, I was like, I want to drop down for the time unit selection. So for time column, we need another drop down put to the right that lets you select an integer common in seconds, milliseconds, whatever, and interpret this in the backend. And so like, I didn't code like a drop down box. Too difficult. I asked Codex to do it. So definitely in the traditional Andrej Karpathy sense. Yes, Bob.
So you did this with Codex, right?
Yeah, I did this one with Codex. Claude Code would have worked similarly, but I was like testing out the Codex model.
Yeah, I guess that's my question. Like, do you have like a routing function for the thing you want to vibe code, and which platform is better for what?
Well, it's actually very simple. So when I'm working on corp stuff, I can charge Claude Code to Meta because we've got that account set up. So I use Claude Code. If I want to use Codex, so I am paying for a $200 pro subscription. Well, not paying. I got comped by Simon Wang. But so I in principle have infinite Codex usage. But Codex is harder to use for a lot of the things I want to do because it's all in the cloud. So I have to set up a full agent environment for like whatever it is that I want to code. And we'll also take a look at that here in a moment. So if I don't have that set up, and for example, I don't have that set up for PyTorch proper, it's kind of hard to like do things with Codex. I mean, you can, but you just don't get any signal. The question was, can't you use CI? And the answer is,
have you used the CLI for Codex?
Oh, CLI for Codex. Oh, I have not. But that one I don't get for free with my pro sub, so I don't use it. Yeah, so I'm very cost sensitive in this sense. Like zero marginal cost, good. API per API, I don't like it. Like I'm always looking for ways to pay a fixed amount.
Yeah. Gemini CLI seems to have very strict rate limiting.
Oh yeah, that's the other thing. Like Claude Code. On the sub, you get rate limited really fast if you're only on like the $20 a month subscription. One reason why I jumped on Codex is because Sam Altman was like, we are not going to rate limit you in the beginning of Codex. So I was like, oh yeah, and like this is 150 prompts over 3 days. So yeah, I spent a lot of money, virtual money in this case.
You save a lot of money. How much?
No. Well, I don't know how much money I saved, but like I definitely like asked it to do a lot of things. Like each of these would easily be like 50 cents Claude Code, for example, and possibly more when the trajectories are long.
This is why we need our own solution.
It's certainly why a lot of people really want a cheap open source model that they aren't paying huge margins on.
Actually, what do you think is the compute that was used for that? Because even if you do it your own solution, you still need the computer to run this.
So what we can do is we can look at one of the trajectories. So it's really important. I'm sorry. Okay, it's really important to look at trajectories when you're like figuring out what's going on with the coding system, because sometimes your coding agent will do something terrible and then realize it's a mistake and back it out. But there's probably something you can change in the environment to make it work out. But this basically tells us all the work that the agent did. So it went ahead and installed all the things. I went ahead and fed it the prompt, and then the agent starts going off. And these agents are trained first to sort of look around, see what's in the repository. This is one of my very early prompts. So there really isn't anything in the repository besides the things that I, manually coded by hand. Like I set up the PyProject toml by hand. I made sure there was testing and, linting and stuff like that set up. And it's just like looking around, blah, blah, blah. And then eventually it's like, okay, well, I think I'm ready to actually go ahead and code some stuff. Actually, did this one work? Oh, yeah. So actually, what you see is that at this point in time, the environment actually isn't set up correctly. It took me a few iterations to get the remote environment working, but you'll see that the agent eventually decides, whatever. The agent figures out how to activate the environment on its own volition. And then now it has a working Python interpreter it can go ahead and run things on. And then it goes ahead and, barfs out a large amount of code. And then it barfs out the HTML file. And then it goes ahead and barfs out a test file. And my testing strategy for this application was to ask it to have some direct server tests. So the server is just a good old-fashioned REST API. So, ping the API, get some result. And I also asked it to, is it here? No, not here. Okay. Later, I asked it to use Playwright to do some browser automation tests. So I'm like, okay, load up the website, click around it using Playwright, and then check that the things you expect to happen helped. This is very, very important. Without the tests to ground the model, it will do things and it will break your old code. So once you get to any level of complexity, when you're doing some kind of vibe coding like this, you need tests. And the tests are very important to make sure you set up correctly, because I did another project, Code MCP, and I asked Sonnet to write lots of tests, and really terrible tests that didn't actually test the thing that needed to be tested. So yeah, you got to pay a lot of attention on that sort of thing. Yes, Boston.
So that's similar, related to what you were just saying. Like, how much auditing were you doing of the produced code versus?
Yeah, so in the very beginning, I was reading all the trajectories and using this to figure out what things need to be done. And I would often you can see that I actually did 3 initial attempts at the initial prompt before I finally accepted this one to start going. Later on, I basically just looked at the diff. What I did was I looked at the diff. Did the diff look insane? No. Then merge it in, and then what I would do is I pull the code and then actually do the thing directly myself, because this is the true reward signal, and check that the thing was working or not. So I was reduced to a Q&A monkey. I would ask Codex to do things. I'd do some more clicking around. I'd be like, oh, this thing is broken. I'd ask, these prompts, for the chip input, the invariant should be that if the field is focused, we see the drop-down box. When we press enter to accept the chip, this should defocus the input field. Well, that's because I did it. And I was like, oh, it's not doing that. I wanted to do that. And I asked it to fix it. Yes, Bob.
Does Codex have memory? So you were mentioning it discovered how to activate your virtual environment. Do you augment your prompt so that it knows?
Yeah, great question. So for Codex, they have a remote agent setup, and the way the remote agent setup works is it's some code. So I just went ahead and checked in the code so
they will always run this.
So it'll always run this at the beginning. So originally, someone told me that I could just source vmfbin activate inside of the setup script, and that would work. It does not work. So you can see that later I added this line, which puts it in the bash RC. That's enough to get the environment in the agent. I don't know if they fixed this since then, but this was something that I slowly figured out as going. This one's also funny because I need to set up the proxy correctly. And the Codex would have been hopeless at figuring this out. This was all done by hand.
And did you write a Docker file? Like it seems like there's already UV in Python.
Yeah, so a Docker would have been good, but at time of writing, the Codex had a fixed Docker file that you couldn't overwrite. I don't know if they fixed this either. I know some of my Twitter pals who were also playing around with Codex were like begging OpenAI to let you provide your own Docker image.
Right, but it looks like you didn't install UV, so it seems like there's just like a
Oh,
basic-
they have a base env and it did have UV, so I didn't need to install UV. Okay, so what do I want to talk about next? Let me think. All right, so I want to point out some very interesting things about this process. So, okay, so one, you see this chart? I did this, I implemented this all from scratch. Kind of crazy, honestly, right? Like you know, if you're like writing an HTML JavaScript application from scratch, you wouldn't implement your like charting library. You go get a library and you go do it. But it was actually like not difficult to do. I'm wondering. Okay, we can actually pull up old versions of the code and look at how it was broken in the very beginning and gradually unbreak it. But I'm not going to do that unless someone really wants me to. But like I was like, okay, let's see. When did I add graphing? So this is called time series. Oh, by the way, yeah, we're going to add a time series view. You know, here's what the line chart is going to be. We're going to do it without any third-party dependencies. Here's how the plotting will work. I don't know if I needed all of this text, but I sort of just like wrote as much detail as I could stand. And there were some things that were broken. Yeah. So I was like, okay, well, I tested this and you generated a bunch of nans in the line. So I asked it to fix it. And then I was like, okay, my test data isn't complicated enough, so give me some more complicated test data. And then there's some like sorting things. Oh, the file got too big, so I then did some refactoring at that point in time. And oh, there was some like I just kept discovering bugs. So one thing that I would point out, because I did some vibe coding with Brian the other day, and Brian was also surprised, and I was like, no, this is just what happens. Is you should expect to like do a lot of turns with the AI. Like you should not expect to get a fully formed thing that works out of the box in a single prompt at any like moderate level of complexity. The thing you have to trust is that you can keep feeding in more requirements until you actually get something that works well, right? Like I've got this graph and it's got all the things I want. Like an analogy that popped up in my head when I was doing this is I was like a sculptor chiseling away at, you know, a big block of marble. So whenever I told the model more things, that was me removing more parts of the marble. So I was getting more and more definition on what it is that I actually wanted. Because I never was in a situation where I changed my mind and wanted the system to do something different. That's like, I've done these sorts of interactions, and that can be quite complicated to do because like you've got all these tests, and the tests are keeping you doing the same behavior you were doing before. So that can be tricky because you need to get the model to not be lazy and be like, oh, I made this change. It caused all the tests to fail. I'm going to fix the test failures by undoing my change. Sonnet, why are you doing this? But if you're just continuously adding more requirements on things that were previously underspecified, this works very well and you can keep making progress for quite a lot of time. I want to pause for a moment again.
Context window gets larger and larger. Sometimes it gets really confused.
Oh,
Sometimes you expect it to remember.
yeah. So this is a
context
great point. So Codex really encourages you to not fill up the context window. And the way it does so is every time I want to ask for a new feature, this will happen in a fresh context window. So this chat transcript, which has a bunch of, you know, LLM gook that it generated to create it. It's really long. Oh my God, it spent so long. on this one. All this is invisible to this one, where the LLM needs to figure it out again. And, once again, it's going to go ahead and read some files, like look at the repo and structure, read some files, right? Like the cool thing about agentic coding agents is that you don't have to like spoon feed them all the files they look at, although it helps. They are trained, most of the models that you are using are trained to, sort of proactively look around, read files into the context, get the context going before they go and do the task. So this saves you the work of having to I was lazy a lot of the time. I didn't tell the agent which files it needed to look at. I just, because this is not a big app. There aren't that many places to look. So it just could figure it out what it needed in that case.
In terms of making this work for production codes, especially with very long like legacy stuff, and I wonder how it can handle it.
Yeah, great question. Okay, well, we can jump track to this problem if people want to. So ScubaDuck is cool. It's a standalone thing. Like that's kind of the best case scenario. We can talk a little bit about how to use AI coding in PyTorch proper, if that's where people want to pivot the discussion to. All right, let's go ahead and pivot the discussion there. So, right. So how do you do it for high stakes situations? So the answer is you don't. Well, okay. So I don't have a good answer. Like the satisfying answer would be like, oh yeah, we need to write a really good agents MD file and like blah blah blah. But honestly, like you should just treat the AI as a way to generate code you would have typed yourself in high stakes situations. So here's an example of something where I use Claude Code to add type checking. Sorry, not type checking, but add types to a signature. And so how did I go about and do this? Well, I first was like, okay, hey Claude, go ahead and add types to process export inputs and add a doc block as well. So I did that. I read it over, and then we did a bunch of back and forth where it was like, Claude had put any here. I was like, oh, I don't want any, change it into object. It had come up with some completely insane signature for the dynamic shapes type that didn't make sense. So I was like, okay, that doesn't make sense, right? Like, really, like, when you are working with the AI on high stakes code, well, this isn't that high stakes either, but like you are exercising your code review muscle, right? Like it's very important to read through every line of code and understand what they are doing. And like the cool thing about working with an AI is, unlike a human where you give them a code review and then the next day they, give you the updated version of the PR, you can just immediately, say, Claude, do it this way differently. And, in a few, like 30 seconds, a minute later, it'll have done the change as well. I did also make some manual interventions here. Claude wasn't able to figure out how to solve the typing mismatch on dynamic shapes output. The reason here is that the dynamic shapes input argument is a bigger type than the output argument, where you've removed the additional inputs and shapes collection types. So eventually I was like, oh, I know how to fix this, and I went ahead and fixed it. But it saved me a lot of typing. This took a lot less time than it would have taken for me to just write this all out by hand. And I also kind of hate writing doc blocks out by hand, so I was very happy that Claude went ahead and did it.
I've another use case I have gotten extreme value in is essentially like for learning about new code bases, especially like you can think about PyTorch as like PyTorch core as like a fiefdom of code bases. So I'll just start Claude Code in like Inductor, and I'm like, explain Inductor IR to me.
Yeah, exactly. I have also done this as well.
And the other thing I was going to say is I have a new feature in Torch.io that is, I think, 98% written by Claude Code. I wrote the hard part, and the rest was like Claude code writing it. One thing I found, you have like a post, Ed, somewhere on your workplace that's like, first implement
Oh
it
no, I don't want to.
shittily, and then figure out how to do it right.
Yeah,
Something
exactly.
like that.
Yeah, so
Claude,
yeah,
like this is
great
the
for
best
that.
use case. You can go into 5 different end-to-end implementations, and you can kind of see which one feels the best, and then you can kind of drill down and like inject your own humanness into one of those, which I have found super helpful.
Yeah, so something like people have said is that, like, you know, Anthropic employees are like, oh yeah, we treat Cloud Code as a slot machine. We like pull it 10 times and then we pick the one that we like. They don't have to worry about costs, so it's easier for them in this case. The other thing I would say is you should look for ways to make things low stakes. So, for example, Wooter recently announced that, you know, we have a bunch of APIs that are public for the CI HUD. Okay, so great. You don't like the HUD? We can just cloud code our own. Like, keep the API fixed, right? Because running an API and paying the infrastructure cost for that, that's high stakes, right? So I don't want to do whatever random stuff I want. But interacting with the API and, like, you know, having a client-side only application that can work with that, easy, low stakes. You can have as many of them as you want, whatever. I want to do something similar to TL parse as well, right? TL parse is 2 parts. It's the you know, actual log generation, high stakes. Humans should figure out what to do. And then there's the, like, oh, and now I just want to, like, go ahead and, like, view the data in a useful way. We had a recent post that I can't share here because this is going to be a public live stream, where I just cloud coded a GraphViz view on an FX graph, like on the spot, because you know, I didn't want to find one that, like, did exactly what I wanted. I had some customization I wanted to highlight the nodes that were dynamic, so I just had Cloud Code do it. Now, it did take a little time. Like, I had to do a bunch of rounds with the AI to get the thing that was working. But I definitely would not have written this software if I had to write it all by hand.
Did you Claude code it into PyTorch, or did you do it?
No,
like
I just made a directory and
then
it was a little tricky because I was processing an internal model def, and I didn't actually want to send the model definition to Anthropic. So there was a little bit of a firewall where I was, like, selectively, like, giving it stuff that was okay to, you know, leak out into the public. So that made it a little harder to, like, code it properly. If you want, go ahead.
Did you add logging code into PyTorch?
No, I used exactly the logs that were available. In fact, it was someone else's TL parse that, like, I had.
Oh, so you just feed in the Dynamo graph article.
Yeah, I just fed in the Dynamo graph.
Oh, I see.
So like, be on the lookout for places where you can, like, make something low stakes. Like, there was some high stakes, you know, infra thing, and now there's, you know, the fruits of the API calls or the data or things like that, and then you can just do one-off things in that case. Like, and then it's a lot easier to do sort of low stakes coding.
Another thing I've been wondering is, because testing is so critical, literally, like, I, for myself, now hypothesis for AI code is like, I don't trust it until I have evidence otherwise. And I think reviewing is even more critical. Like, it requires a lot of domain expertise to review it and make sure it's doing what it's supposed to do. Should we have an even higher emphasis on reviewing codes, like group review, make it more formal even, or make it mandatory? And just so that we make sure, you know, everybody with the domain expertise can be pulled in. Or some other way. Like, besides, you know, you talked about move high stake to low stake. Basically break it down into, you know, blocks, right? Something like that. And then testing. But should we do even more group reviews, more like, you know, testing framework, just to make sure?
Yeah, this is a good question. So how would I say this? Okay, so the point of getting code to be low stakes is so that review is not needed, right? Like, if I have a little one-off script, I'm not going to ask someone to code review it. Waste of time, right? Like, I don't need anyone to review the ScubaDuck code. Like, maybe someday I will read it because I can no longer make changes to it. But like I don't need to know what's in the code. I know that it's doing something useful for me. It doesn't need to be production like critical. It's not production critical, whatever. When we're like trying out Cloud Code in high stakes, like the PyTorch codebase proper, I do agree reviewing ability is as important as ever, if not more important. I actually, this is a conversation that I've had in the past, even before AI coding, which is along the lines of like, how do we get people to be good code reviewers? Like, what does this on ramp look like? One like common story is you write a bunch of code, you like own the code because you like know where everything is, and then you naturally fall into the reviewer for the system in question. Another way is like it's like there's some code you didn't own it, but like now you have to own it. You spend a lot of time understanding the intricacies and figuring out what the internal intention is. And like for me, like a lot of what like being a owner slash maintainer is about like maintaining this internal mental model about what the system is supposed to do. And this is different from what the system actually does, right? Because what the system actually does, like there can be bugs, there can be, things we patched on as a last minute hack. But like, I always like to think there is some platonic ideal of what the code should be doing. And then as a reviewer, your job is to like basically tell people if you're in the right direction or not. So to answer your question, G, yes, reviewing is important. I don't know if that means like we should do joint reviews or we should go around telling everyone that, hey, you should work hard on your code reviews. I'm not sure what the answer is there. One of the things that like is something that I do want to use Cloud Code to do more in the PyTorch codebase is refactoring. Like I hate that our test files are so large. I would like Cloud Code to like, split them up into smaller files. How do I want to ask people to review? I don't know. And like if I actually did something like this, I would be heavily bottlenecked on review speed. Sometimes I like feed diffs into Gemini and ask it to look for non-semantics preserving changes. I don't know how well this works though in practice. Yes, Bob.
Yeah, that's what I was going to ask. Like, I listened to a podcast with a few Anthropic people, and they're saying that they actually include Cloud Code as part of their CI workflow. I think the two examples they give was typos and then like big security problems. And like, I guess I'm curious of your thoughts on like, do you think there is anything where, maybe we just tune it so only for like obvious red flags we comment, or do you feel like it'll probably be too noisy?
I mean,
For typos, we should just use code spell.
Yeah.
I'll say there's better tooling, but yeah, there's probably some degree of code or like human in the loop enforcement.
I guess they have a vested interest in making Cloud Code as part of the CI, so they get more tokens.
I mean, but look for major security vulnerabilities. This is not a great example for PyTorch because we tend to have a very strange security model that like means you basically it's very hard to write insecure code in PyTorch. But like in general, like that's a good thing. Another thing is like checklists. Like whenever you have a checklist of things that you're supposed to like look over before you do a PR, that's something LLMs are very good at, right? Because they will always review the checklist and always studiously like check everything off. You don't have to worry about them getting bored or lazy or things like that. I know that the dev infra team is trying to get some sort of Claude thing going so we can do things like that. And you can also request Copilot review on pull requests by just adding Copilot as a reviewer. I've seen Albin put it on a few PRs. It hasn't looked very useful. That's the thing about AI code review. If it's not useful, then you just like do your own review anyway.
Yeah, I mean, one thing I was about to say actually is I think we have some way to customize the prompt for Copilot when we ask for it for review. So I think we most likely want to spend a bit of time figuring out what's a good prompt so that it is helpful. I think in particular things like, is everything documented? Is there CI? Is there public API? Is there testing? I think the kind of thing of like, can we reduce the amount of back and forth we have to do on a PR before accepting it, and have Copilot do a bunch of them? Might be short term the best use for it. Yeah.
I was just gonna say, I think it's possible. Like at least with my recent like work on VLLM, like they use Gemini for review and they like use it. I think it provides meaningful signal that code reviewers actually like look at before they do the review. I will agree that Copilot has like actually told me the exact opposite thing on some reviews. So I think it needs some work, but I do think there's probably a path in this forest of how to get Copilot to work better or some other tool.
Yeah, and I think as we were mentioning, we're gonna have to do more and more reviews. So whatever part of the review we can offload, so we focus on the critical piece, which is that the right direction for this global view, is most likely going to be helpful. Yeah.
Goji.
I have a few thoughts. So number one is if I ask Gemini to review a piece of code and then offload that to the AI without doing the job myself, I feel very nervous about it. Like, what if it picked out something useful, but not everything critical is picked out? What I've found again and again is when I have some actually pretty important questions I really want to know the answer to, I will try a few different ways. Like, if we have Gemini, Cloud, and Copilot, all do the review and then compare notes, see what's common among them and what's different among them. And over time, I have found out that different AI is really particularly good at particular things, probably depending on how they're fine-tuned and post-trained and everything. So something like knowledge, basic about how this AI really work is actually really, really helpful. Now I have more ideas about if I have this type of question, I will ask this. Sometimes I even poke Grok for whatever bizarre reasons, and I want to know. But and also, I think offloading is a dangerous thing in whatever sense. I still hope some kind of human intervention is still involved on things that are not extremely low stake. So in the end of the day, it will be a bucketing of stakes. And then we draw a line about where a human review is actually not needed. But then above that, we want to be very careful and test different chatbot solutions.
I actually have a simpler claim, which is that, like, at least today, at the end of the day, you own your review. You can use an AI to help you, like, find things, but, like, at the end of the day, if the, PR causes a sev, like, as a reviewer of the PR, you also should get pulled into the sev, right? And if someone asks you questions about the code, then, well, I mean, sometimes we do like very strong reviews because we're going to jointly own the code with the person who wrote it. Sometimes we do weaker reviews because we're rapidly iterating on something, and we just need to like know kind of what is going on and are willing to backfill some of the understanding at some future point in time. But at the end of the day, you're owning it, right? Like the AI doesn't reduce your standards. Like we should still judge people by the same standards we did with or without AI.
Maybe even higher standard with AI. No?
I think with AI, it tends to be different. So, for example, there are certain problems that, like, as a human, I might make that I don't have to worry about an AI making. And vice versa. NYC.
I think maybe what you mean, G, is like with the AI, you'll be faster at doing the review, or you'll be able to do more. But I don't think the standard and the expectation on the review itself should change.
Yeah.
The bar is the same for a given piece of code, right? The bar is the same. You might have a new, more efficient way to reach that bar, but the bar doesn't move.
Something in that line, but actually it's a little bit more about how AI should shape the way we do our job. And so we do some certain things a lot less, like, mundane tasks and stuff like that. We do certain things a lot more. And then the more bucket includes reviews, reflecting and examining the outcome and everything. And then in the end of the day, we should be able to do a lot more than what we used to be able to do with the smarter and smarter AI. So this is actually that line of thinking. Um, yeah, but standard is a great way to call out.
Sorry, Dres. I would add as well that I think this is exactly the same stance we have for PRs. Like, in the end, you own the PR you send, whether you used AI or not to generate it. It is your responsibility to send a PR that makes sense. And if it's bad, it will be on you that the PR is bad. You won't be able to blame AI, and it will be your troubles.
Yeah, humans
Chris?
responsibility.
I was just gonna say, like, in the context of review, my current worldview is that the AI comments are just another source of signal. And like where in that signal stack we place it is, or like an individual reviewer places it is interesting. I put it towards the top. And so like similarly, if a PR is failing tests on CI, that is like a strong source of signal that something is wrong. And if the AI, like, that's like at the level I place it, and then for like actual important changes, the human should be in the loop. So it's just like a filter, I think. Today, a week from now, maybe it will be like the main intelligence that decides what gets approved, but current mental model.
I have a question for the room, which is, are we review bottlenecked, or is it okay? Are we like already teetering at the brink of catastrophe and will be pushed over the cliff by AI coding?
I would say yes, personally, but
I would say yes.
Yeah.
Okay.
Do we see it in the data G? Like the time to land has it increased?
I don't know if G has those numbers
Maybe G's muted.
right now.
No, have you guys heard about the conferences being overflown by submissions? They are clearly review bottlenecked, I would have to say.
Yeah, that makes sense to me.
oh, that as well, yeah.
But for data science work, I'm very extremely concerned because I worry that people produce SQL without enough examining the codes and generate data that can really skew the decision making in significant ways. And I'm very worried about that. I don't know how to handle it.
Oh, I guess my question is more so around like the average time from pull request submission to pull request land. Like, has that increased? Because if it's the case that we're really bottlenecked, you'd expect that time to have increased recently.
I would say two things. One is we have 1,300 open pull requests right now on the repo.
But we always have a bajillion open pull
We
requests.
always have a bajillion, but we have a bot that closed them after inactivity for more than 3 months. That means in the past 3 months, we opened 1,300 pull requests that are still here. And two, I think I don't expect to see the time to land to go up too drastically, because I don't think that's something that at least is in the meta culture. The meta culture is more going to be, I will pressure people into reviewing less and landing my code, not, oh, it's okay if these features don't land, and the excuse is going to be we don't have enough reviewers. I think they're going to land one way or the other. And I think it's more, less review is going to happen to continue landing whatever needs landing.
Okay.
You're saying that the time that a PR stays open will remain constant, and we will increase the number of PRs, and thus we will land less reviewed like amortized over the sum of time spent on them PRs.
Should look at the average number of comments per PR. That might be going down, yeah.
This is also affected somewhat by the CI time, which will be negatively affected by more PRs.
Well, I think our friends at AMD are troubled by that. Yes.
Are we review bottlenecked or like change bottlenecked? Meaning like we are adverse to change in certain areas because of the ramifications of like, I don't know, BC or whatever. Do you know what I mean by that?
Yeah. I think the design of some of these is part of the bottleneck. I would agree. Yeah. Yeah. Like a lot of these reviews that take a lot of time is because there is non-trivial design decisions that go into them. Like, I don't know. This morning I was looking at that stack from Intel. Like, hey, we need to migrate all the allocator configuration in C++ and make them generic. You know, a lot of the review there is like design and, you know, what is shared API, what is not, how do you want to do all of these things. That's where you spend a lot of time in these kind of reviews. But I think it's part of the review work, yeah.
I think even outside of design, I feel pretty review bottlenecked for things that are just a little more trivial, like things that are not big design heavy for like LR scheduler or whatever. Like it just takes time to read and make sure it's okay. And in that sense, I still feel the bottleneck.
So I won't claim this is a silver bullet, but like one thing that is an easy way to like change the equation slightly is to put more onus on the PR submitter for things. Like whereas previously you would have tried to like slug through the code and figure out what it did, maybe now you just say, I don't understand this. Please explain. Go, Mark.
Yeah, I was gonna suggest something similar, which is that like PyTorch reviewers are quite friendly, but like you can sort of like I guess now you have more of a carte blanche to ignore low quality work or close it, and you're like, hey, the bar is higher now because I expect you to have already done the for loop with LLMs on your end.
If LM is smart enough, maybe it can help explaining the code and pointing out what does not make sense, and then automatic file task for the PR creator. Could that help? I don't know. Alban, do you think?
Sorry, can you repeat?
Oh yeah, I said if LM is smart enough, you can go scan through the PR, identify where it makes sense or does not make sense, create a summary about what it's trying to do, and then create a testing framework, like automate all of these. And so the reviewer literally will be reading through the summary, and then the PR creator would be receiving tasks if some things don't make sense.
I think yes, and I think that's a bit of the idea I had earlier about like reducing the number of round trips. There are any round trip that the AI can have with the author of the PR without the reviewer being involved is a win in a world where we are reviewer bottlenecked. Correct. And I think it feels like it's a bit of the same idea that Ed was describing earlier about the writing code part. Is like, you know, you are mostly, as the reviewer in this case, you are mostly here to have the high level vision and understanding of where you want to go. And the LLM is doing all the nitty gritty details to make sure that the execution happens. And you just validate at a slightly higher level that things are happening. Except that in this case, the LLM interacts with the person that's in the PR. Yeah.
Go, Jess.
I was gonna say something similar to what Alvin was saying, but I've gotten like super bullish on Cloud Code, and there's like a term flowing around the Twitterverse which is like context engineering. And I just felt like this is the first time I have found it like extremely easy to provide the right context to these AI models, which is great. I think the bottleneck for review in PyTorch is this implicit context that like the Eds and the Albins and the Natalias and the Zachs have, which is this overarching worldview of where PyTorch is and where it should go that is just like not in the code. And I think that is like, at least I have seen on these like super big PRs that take forever to land. It's just because like that information needs to flow to the actual authors, and it's just hard. And I think that is going to stay there for a while unless there's like ways to like virtualize ed.
It's actually really something that I thought of saying after I heard from Alvin earlier, which is we have an internal agent built that is pulling people's contacts based on your SQL history, and then build a analytics plan, SQL writing and stuff like that based on that. But in the world, for PR for PyTorch repository, imagine the day we have an ad bot, we have album bot, and we have like a combination of the people, and then pulling their history, including the interaction history of on the entire repository, and pull that into some kind of context, and then people who use the agent for reviewing will automatically apply those contexts. And it's probably something pretty feasible to act on today, I might imagine. So the ad bot would interact with the PR in a way that is, say, 70% or 80% to what Edward himself will be doing. And that's good enough, because that will save a ton of time already.
Maybe. I think the problem with those is they like are stationary, where Alpin and Ed gain feedback and update their priors on what they think PyTorch should be. I don't know, maybe you can
Retrain the agent every month.
Yeah.
Well, in the future, I really think things should be continuous training and pick up new context on the fly and stuff like that, hopefully, so that things don't get stale. Recency is really more important.
One thing I would add as well for like some of these more niche use cases, I think that, for example, multiprocessing was hanging on macOS, and Nikita was investigating it. I spent a bunch of time trying to help him there. We have zero expert in multiprocessing. CPython barely has one, and we need to understand, get a PR and fix that. It's not like I can easily review that. I need to sit down and understand exactly what's happening, because I don't actually have prior knowledge on that, and I need to rediscover it. I need to read the CPython code base to understand what the hell they're doing there, what they changed, and why that weird cherry pick they added recently like makes everything hang on macOS, and read the fork and exec system calls, what they do. I feel like for me to, as Ed was saying, like at the end of the day, I need to be confident about that review. And when I say I think we should merge that for our whole macOS fleet and it's going to be beneficial, I think I need that time to actually sit down and understand all of these things to be able to make that review. So I don't think I would put that caveat that, I don't know for Ed, but for me, I don't know all of these things. A lot of these things I rediscover on the fly, and I just have enough context that I can rediscover them faster, maybe. But
Just like an
it's not like
LLM.
from the NPR, I wouldn't be able to just, oh yeah, it's obviously correct, or it's obviously wrong. It's nowhere near that.
Okay, I have a hard stop at 2, so I think that's a good place to end. Thanks for lively discussion. This will not be the last discussion we have, I think. So, all right, see you all later.
Thank you.